Hi everyone, and welcome to One Less Problem. Today I'm going to show you the final way on how to solve a systems of equations with a different method called the elimination method. So the elimination method is every student's favorite, mostly because it is the easiest. Usually once we teach the combination linear elimination method, students usually ask, why didn't we do it this way first? The reason is a little piece of it kind of goes back to the previous video on the substitution method. So just like I do at the end of every video, I will show what the pros and cons are of the elimination method because it's great, but it does take some time to kind of get an eye for it, and that's why I drew a little eye here, because you do have to notice when is the best time to use it versus the other ways which you might already feel more comfortable doing. So by the end of this video, you have three ways to solve systems of equations. Oh my god, I'll wait for the trains to stop. So by the end of this video, you will have three different ways to solve systems of equations, and you'll know when is the best time to use them. Essentially, the reason why you learn three is because you're kind of learning shortcuts, and you're learning what's the best way to go about this and what's the most efficient time for you, so you're not wasting a lot of time. So I don't really want you to take notes for this. I want you to do the example in your notebook because that's probably the best way you're going to learn this. So let's take a look at our example. Here are our two equations. We have 7x plus 2y equals -1, and the second one is -7x plus y equals 10. So, there might be something you notice about this problem. Both of these equations are not in slope-intercept form. They're in a form that we call standard form, and all that means is that there's a coefficient in front of x, there's a coefficient in front of y, and then there's a number that it's equal to that it does not have a coefficient. And usually the variables go in alphabetical order, and it's usually 2. So this is what we call standard form. It's kind of easy to get an eye for these problems when they are in standard form. And usually when you're given these problems, if both of them are in standard form, that's when you should ask yourself, is there a way that I can eliminate these numbers? So let's go ahead and try this problem, and I want you to do it with me. But the first thing you need to notice is, look at the two equations and see if any of the coefficients are the same. So if you look here in front of my x's, I have a 7 and a -7. They both have the same number, but one of them is negative. If you take a look at the other one, we have 2y and 1y. They're not the same. So as you go through this, you're trying to figure out which terms you can eliminate, and in this case, 7 and 7 are the same. So, since 7 is a negative number, ask yourself, if you were to eliminate it or get 0, how would you eliminate 7 and -7? Would you add them together or would you subtract them? 7 plus -7 is 0, therefore it's eliminated. So you're going to treat both of these equations as one big addition problem. So I want you to put a big old plus sign like this, and we're going to turn this into a huge addition problem. Every time you go through each term, every time you get to a term, you're going to treat it like it's its own problem. So 7x plus -7x gives us 0. It's eliminated. That's why we call this the combination linear elimination method. I think I just made that up. Then we have, look at the next one. 2y plus 1y gives us 3y. And -1 plus +10 gives us 9. So just like that, we're already at the step where we can solve for our variable. Obviously, the y is equal to 3 because we will divide each side by 3, and this will be our answer. So just like in the last video where we talked about the rules of substitution, you're not done yet. And if you don't know what I'm talking about, go back to the last video. These are the notes. You're not done yet once you have a part of the solution. We still have to find out what x is. So you still do the same thing that you would do in substitution at this point, and you would take the y, or the x, whatever you solve for, and you would plug it back into one of the original equations. So we're going to do that right now. My y was equal to 3. I'm going to plug it in, and you can choose. I'm going to choose the top one, 7x plus 2y equals -1, and I'm going to plug 3 into the place of y. So when I do that, I can plug in 3, and I will get 7x plus 6 equals negative 1. Now, I just have to solve for x. So subtract 6 to both sides, and you should get 7x equals negative 7. Last but not least, we can solve for x by dividing both sides by 7, and our answer will be x equals negative 1. So just like that, we found both of the solutions. I should say we found the solution in both of the numbers in that solution. X would be negative 1 and y is 3. Just like in the other ones, you do want to check your solutions. So plug in both of them to see if it comes out right. If I plug in negative 1 for 7, 7 times negative 1 is 7. 7 times negative 1 is negative 7, plus 2 times 3 is 6. Is negative 7 plus 6 negative 1? It is. The next one, you don't have to do it, but you should always double check. Negative 7 times a negative 1 would give us a positive 7, and 1 times 3 is 3. So is positive 7 plus 3 10? It is. It checks out. So you should always do that at the end of any of your systems of equations. The next thing I want to talk about is, in order for the elimination one to work, like you notice, it's pretty fast. It's probably the fastest one, and you don't have to graph. So you do want to note that sometimes it's not always going to be laid out this nice. For instance, sometimes you could get a problem that is, let's use the problem that we had here. If we had 7x plus 2y equals 1, and 7x plus 1y equals 10, even if I take that negative away, this is when you have to ask yourself, well, if I wanted to eliminate this, would it become an addition problem like how we did here, or would it be subtraction? Well, in this case, we would want to use subtraction for everything, because 7 minus 7 would give us the 0. It would give us the elimination that we want. But just remember, if you choose subtraction for this portion, you have to do it for the rest. So we would do 2y minus 1y. We would do 1 minus 10. So that's just one thing you want to keep an eye out for. The other thing that you want to look at for these problems is sometimes you're given equations and they don't have the same coefficient. So this one's nice because they were both 7. But let's come up with a problem like this. Let's say we had 2x plus 3y equals 8 and 5x minus 6y equals 2. You can use the elimination method for this, but the first thing you want to do is always look at the coefficients. I have a 5 and a 2. They're not the same. I have a negative 6 and a 3. They're not the same. However, what you're allowed to do is manipulate an equation by multiplying or dividing. So ask yourself, is there a way that I can get 2 to become a 5 if I multiply or divide it? There is, but try to keep it easy for yourself. Is there a way that 3 can become negative 6 or become a 6? And yes is the answer. 3 times 2 gives you 6. So since I can make this become a 6, I would multiply everything here by 2, because 2 times 3 is 6. It would give me the coefficient I needed to eliminate it. But if I do it just to this number, I have to do it to the whole equation. So this whole new thing would come out as 4x plus 6y equals 16. Now you can see that a negative plus a positive 6 is what would give us the elimination, and then you would solve for the rest of it, just like how we did in the other problem. So we talked about making it into an addition or a subtraction problem. We talked about multiplying the values or the coefficients. We talked about multiplying the coefficients to something where you would be able to use the elimination method. And there's one more weird rule, and that's why I wanted to put this here. Sometimes you get two equations where the coefficients are exactly the same and they're the same sign, meaning positive or negative. So if I were to eliminate these terms in both of the equations, I would turn this into a subtraction problem, because 3x minus 3x would give me 0. It would eliminate. But then I have a positive 2y minus 2y. That would also eliminate. So really, there's nothing left on this side of the equation. It would technically be 0. So if I were to do 11 minus 8, that would give me 3. Well, is 0 equal to 3? It is not. Therefore, this would be no solution. And just like in our other videos, we saw no solutions. That happened when we were graphing and the lines never crossed, right? So if we were to put both of these into slope-intercept form, they would have had the same slope. They would have never intersected. In fact, it would have been what? -2/3. So keep in mind that all of these no solutions or infinitely many solutions do come out in any form, in any method that you use to solve these systems of equations. If I were to get the same thing, then we would say infinitely many solutions, okay? If the 3 was equal to a 3. In this case, it's not. Or a 0 equal to a 0, it would be infinitely many solutions. So this was pretty quick. This is why students like this method. You do have to practice with it, and you do have to get an eye for it, because if they're not in this form, if they're not in standard form, you might have to rearrange it. So let's talk about the pros and the cons. Students like this because it is quick. People like it because it's clean, it's to the point. You can visibly see how everything eliminates, and you're just left with a variable that you have to solve for. And the last one is, it's nice when you're given the equations in standard form, because you can easily spot what's going to eliminate. The cons are, if you like this way, you do have to rearrange the terms, usually. Because if you had something that was in point slope form, like y equals mx plus b, this won't always work. It won't be that friendly for you to use. But nonetheless, you can still use it. The elimination method is nice when you are doing what we do and only solved systems that have 2 equations with 2 unknown variables. And you're able to use this when you get into more complicated math, because sometimes you're given 3 equations that have 3 variables in them, and so on and so forth. So this is really nice when it's 2, it's easy to spot, but this method could be used in those more challenging problems. And then the other con about this one is you really have to know your rules of negative integers, because if you're someone who didn't notice that 7x and -7x, if you didn't know that adding them together gives you 0, this is going to be difficult for you. So knowing the rules of addition and subtraction with using negative integers is needed for this. So if the con I'm saying is, if you're not good at this, then you might have a problem with some of these questions when it involves negatives and subtracting negatives. So I guess I should say, when in doubt, use your calculator, but you should really know these rules by this point in your life. Thank you for watching this video. Feel free to like and subscribe.